Alright guys, so here are the 3.4 graphing and slope intercept form notes. So, instead of making tables of values every time you need to graph, there is a more efficient way as long as the equation is in the form y equals mx plus b. This is called slope-intercept form. The slope is always the m that's in front of the x, so this is called our slope, and b is always the y-intercept. So then if we come down here to this equation, we can see that the slope is in the front, so negative 1/4, so negative 1 over 4. And then the y-intercept is in the back, this negative 1. But as we write y-intercepts, it's always x value first, so x comma negative 1 for y value second, just like writing any other ordered pair. So then how do we graph this? We start at the y-intercept, so 0 comma negative 1. We plot that point. And then from here, we just follow the slope. Negative 1 over 4 tells us to go down 1 and then to the right 1, 2, 3, 4. So like this. Or we can consider it as 1 over negative 4, which would mean to go up 1 and then to the left 1, 2, 3, 4. So there's two ways you could consider that graph. And then after we graph those 3 points, we're just going to draw a line straight through them. And then what that builds is the graph of the equation. When talking about domain and range, this is going to go to the right forever, and it's going to go to the left forever, so the domain would be all real numbers. It's also going to go down forever, and it's going to go up forever, so the range would also be all real numbers. For this next graph, right, we have a slope of 5, so the slope would be 5. If you struggle with understanding slope when it's just a singular number, you could put 5 over 1. The y-intercept in this case would be 0, 8. And then so we're going to start and we're going to graph 0, 8, and then we need to follow the slope. So this slope would say go up 5 and to the right 1. Well, if we started going up, we're going to go straight off the graph. So another way to graph a positive slope is to consider them both negative, right? So we could go negative 1, 2, 3, 4, 5, and then to the left 1, that's going to give us a point. And for graphing a line, you actually always only need 2 points. So then here's our graph. The domain again, all real numbers. The range, also all real numbers. So the domain and range, as long as we have a graph in slope-intercept form, will always be all real numbers. This last one in slope-intercept form that we're going to look at is right here. Okay, so the slope in this case is actually a special one. There's a 1 out in front of this x, because if we take 1 and multiply it by x, it just stays x. So the slope is 1. The y-intercept, we need a value that doesn't change the x. So a value that we could add to x that wouldn't change it would be plus 0. So the y-intercept is going to be 0, 0. So then now we can plot that y-intercept, 0, 0. A slope of 1 tells us to go up 1 to the right 1. And now that we have 2 points, we can graph this. Again, the domain and the range, both all real numbers, so we're good there. All right, and so that's graphing in slope-intercept form. You just graph the intercept, and then you use the slopes to graph from that. The following equations do not look like y equals mx plus b, but can we still graph them? Yes, we can is the answer. Whenever we have y equals without an x in it, this is actually a horizontal line. And it's a horizontal line that goes through the value y equals negative 2. So we go negative 2. And then we just draw a horizontal line through there. Well, the slope of a horizontal line, right, just for some review, is going to be 0, because you would rise 0 and then you would run some number, like if you went to the right 1. So then the slope is always going to be 0 here. The domain of a horizontal function is all real numbers, because it goes to the right forever and to the left forever, and domain deals with the x's. The range of a horizontal line, though, is just the y value. So it's just negative 2, and then we're going to put curly brackets around it, or you could put regular brackets around it. Either one of those is fine. For one like letter E here, this is telling us that no matter what we use for y, x is always going to be 6. So this is going to go through the point 6, and then if we did 1 for y, it would still be 6. 2 for y would still be 6. 3 for y would still be 6. -1 for y would still be 6 on the x value. So this is going to build a vertical line straight up and down around 6. Let me just move this. Okay. So then our domain is just 6. That's the only x value that we get. But the range, we could pick any y value. So that's going to be all real numbers. Remember, the slope for a vertical line would be, we could rise, who knows, infinite number of times, right? So if we rose 1, how far did we run? We ran 0. So this slope is always undefined. Okay? And so these are your notes for 3.4, graphing in intercept form. If you have any questions, just message me on Canvas. I hope you guys have a great day.